Okay, so today's session, working with tabular data in GIS, we're going to dive in and work directly on those attribute tables. That's our goal today. So learn how to do things like query a table to identify and select a subset of records in your data based on some criteria or set of criteria. We're going to learn how to join tables together, basically add more information to an existing data set. And we're also going to geocode, which is kind of a continuation of our data creation last week, where last week we started by adding these a table of latitude, longitude coordinates, right? So we know that these refer to a specific point on the Earth. Geocoding is a process that converts a description of a place into, say, a latitude, longitude coordinate. So you can take a street address and link that to location on the Earth, for example. So we'll do some exercises on all of these things. And we're going to start with that geocoding. So here we're going to take some sort of description of a place, right? So a street address has a house number, or a number has a street. It also has a road description, whether it's lane, road, highway, whatever. We can use that information to tie that to an actual coordinate. So say a point feature to represent it. This could also be a general name of a place, say all the national parks or states or monuments. You can even do it with IP addresses commonly. If you know geographically where the hosted router is located, you can tie those IP addresses back to the Earth. So geocoding is this general process of using a description of a location and turning that into coordinates. So what this process really needs is a database of reference material, some reference data set where you're going to look up every entry and compare it to a reference to try to match a description to a location already in a database. So you need some reference material for this process to work. There's lots of different ways to perform geocoding or tools you can use. Google Earth Pro has geocoding tools within it. Google Fusion Tables, if you're a programmer or developer and like working in APIs, Google has an API for this as well. There's different websites you can go to. Some look a little iffy, but work well. They kind of have a lot of ads on the sides, but actually perform the functions pretty nicely. What we'll do here in the middle using ArcMap. So we have here at the university purchased some geocoding data sets. And these databases of reference material, and there are tools in ArcMap that are very powerful and flexible that allow you to perform this process. Esri also has in ArcGIS Online, I guess, as well as ArcMap, their own geocoder. What this does is it uses credits associated with your ArcGIS Online account to do the processing. When we do ArcGIS Online later and talk about credits more, this will make sense. But for those of you here at Clemson, you have 1,000 credits to your name, to your user account. Geocoding is one of the most expensive things you can do. It's about 1 credit for 10 records, which means that if you did 10,000 entries in a table, you would have exhausted all of your credits in one go, which is very easy to do without knowing. So we're going to show you how to do it in ArcMap. It doesn't consume any credits on your account, and it's much more flexible. You can build your own address locator or your own database of reference material and ways to link descriptions within it. So if you need your own customized geocoder, you can build these yourself. So when we do this process in ArcGIS, there's one of the really nice features about it when we do it here in ArcMap is that there's no limit to how many records can be in your input table. You could have 100, you could have 1 million, it just may take a lot longer. the engine that drives this is very customizable and flexible. And so we'll go in and adjust some of the parameters just to show you how this works. It's a little bit picky in terms of the input data. So the data need to be fairly clean and organized in a specific way for this to work effectively. So we'll go through a table today and look for things like spaces, special characters, and get rid of those before we start. It uses CSV files, so comma-separated values, or Excel spreadsheets as input, so some common table formats. So when you actually run this process, you'll feed in a table, you'll choose the locator that you want to use, this database of information, and then it will read through and give you all of its automatic matches based on your criteria, which comes out in this results list. And what you'll often find is that you will have locations that it can't match. So in this example, there were 500 input records. It automatically matched 496 of them. There are also tools to go back in and manually assign these to a location. And we'll do a demonstration of that as well. So how does this process work? First is to standardize your address or your description. So for example, with a street address, we're going to break down that address into all of its component parts. So we have our house number, the name of our street, the type of street it is, lane, road, drive, city, state, and postal code. And then what it wants to do is compare each of those component parts to your reference data. So your address locator will take your input and compare it piece by piece to whatever's in your reference data. And then it will score each of those pieces. So in this example, if it finds the exact house number 26376, it will assign it a score of 100. If it finds, let's, for example, say 26375, it might give it a 95 or some lower score. So it generates a score for all of these. And then it's going to sum all of those scores together and give you the best candidate. So you may get a number of different candidates that have various scores. So it will automatically match to the best candidate. And once you've tied that input to the candidate, then it will output a point at that location. So does that make sense? Questions so far? All right. So again, this address locator is a tool. That's the terminology in ArcGIS is an address locator. And along with that, it has some reference data. So those reference data would be things like streets, addresses, cities, states, and zip codes in our example today. The address locator builds in rules for how to interpret or split up the address and assign those to locations on the road. In this example, even house numbers means the left side of the road. It will also give flexibility to say interpret street components differently. We as humans can see the letters AVE and know that represents avenue, but we need to tell our computers specifically that those are the same thing. So it builds in some flexibility into the process. So our workflow for when we perform geocoding, I guess they've all showed up at once here. We first build or obtain our reference data. And again, we purchased some data sets that we'll use today. We'll determine our address locator style. We're going to work with street addresses, but these can also be things, again, like national parks. It could be counties, states, zip codes, FIPS codes, all sorts of stuff. And then you actually run the geocoding tool, which will locate the addresses and do this process of rematching things that didn't fit. So our reference data, we have Esri street data that we'll be using today. Some other places you can go to obtain this yourself. The US Census through their Tiger Gateway has geocoding data you can use to combine any sort of general gazetteer or atlas data, say our NavTech or TeleAtlas. You can compile your own reference data here, or things like a database of zip codes might work for you. What's really cool about this process is that it can link to points, it can link to lines, or to polygons. So if your reference database consists of zip codes, you're going to match things to polygons. What we did last week with matching coordinates were restricted to one type of geometry. Right? We could only get points out of that. But through here, you can actually link up a table of information back to lines or polygons specifically. Questions? How many of you right now think that you would want to know geocoding? Have a need for it right away? Quite a few of you. Okay. In my experience, people who work in history and public health do this all the time. And it gets really frustrating for those who work with historical data because city names change over time, counties change, all of this stuff is constantly changing. So you have to update your reference data or build your own. I have Jennifer remotely says she needs it. She's the one who works with campus safety and police services. And she's trying to do this right away. So for those who are working remotely, you've downloaded the geocoding data directly. It's stored in your Working with Tabular Data folder. For those of you in the room, let's open our Windows Explorer. We're going to connect to that network drive that contained our geocoding database, our address locator. Whoops. Once you've opened this window for the Windows Explorer, click Computer on the left. And then click here, Map Network Drive. You can assign any letter you like, but our folder, let me pull up my PowerPoint here. You're going to type in this address for the folder. So 2 backslashes, that's the one above the Enter key. libstorage.clemson.edu/GIS. And then click on Finish, and it will prompt you for credentials. You're going to use your username with @clemson.edu after it. And I just realized you four may not be able to access it.
Language based if you didn't ask for it.
Yeah, you guys maybe. Yeah, any letter is fine. Any drive letter is okay.
Yes, no, that doesn't matter.
The next thing to try, your username with @g.clemson.edu. If it rejects you @clemson.edu, try with g.clemson.edu.
Yeah.
Okay, who's successfully done it so far? Good, if you did this. No.
Yeah.
Try to use another account. So use it Okay, did you try that? When you include your credentials, Okay, we're in. No, so you need two backslashes. Here's the assignment. And then backslash. Try first, you're using it. Okay, who still does not? Try using other. You're using it as a G. So, is anybody still not connected? We're all good. Okay. Awesome. Yep. For those of you remotely, you should have the data already stored in that Working with Tabular Data folder. There was a Geocoding Data zip file that you'll need to extract. You do not need to connect to this network drive. For those people on campus, it's more convenient for us to have them do this. Okay, so everybody's got this window here. They're connected to our network drive, lib storage. So there are these three folders. Geocoding data, you can see the years. We're going to work with data from geocoding, or from 2014. So our Geocoding Data 2014 folder, go into Geocoding Data. And you'll see there are these, what you might expect to see for GIS data are a number of things with the same name and different extensions. So we have our zip codes, USA Geocoding Services, street address, city, state, and address points. These are all different styles of address locators. So you can see one will take zip codes as an input. Some will take a city and a state and assign it that way. We're going to use street addresses. We're going to leave all the data where it is. You can minimize this window, but we're going to set up a folder connection to that spot in just a minute. So, all right. So everybody's connected, knows where our geocoding data are stored. Let's open ArcMap. Nope, sorry, let's not get ahead. Let's take a look at our data first. So let's go to our Data 2 drive. We're working with tabular data folder. And there's this Excel spreadsheet called TRI Facilities 2014 Raw. Go ahead and open that Excel spreadsheet. How many of you are already familiar with TRI facilities? Nobody. Okay, these are, they're a data set that comes from the EPA. And what you can do is, where's my? So there is this ToxMapper service where you can download EPA data. So there are facilities all over the United States that obtain a permit through the EPA to discharge chemicals to the environment. And as part of that permit, they have to report the mass of contaminant that they've released across a variety of chemicals. So here at the top are different years. These data come from the year 2014 that we've downloaded. So if I click on TRI 2014, you can also zoom to a location. I just went to South Carolina. And it will download to a file everything that shows up in the map, which is where I got these data from. So just to show you the source for these. So when you download the data set as this table, you can see it has a bunch of information, a facility ID, a name, address, city, state, zip, county, FIPS, lat long, and then all of these chem 1, 2, 3, 4, 5. So they're required to report the 5 most commonly released chemicals for each of their facilities, and then the mass. So this is going to be our data. We're going to create a data set in GIS out of these by geocoding them. So the things we need to look for and clean up. First, we need the column names or our attribute field names to be in the first column, sorry, the first row of our table. So anything above the names of our columns needs to be removed from our spreadsheet. So these first 5 rows up here, we can just get rid of those. So I'm going to select rows 1 through 5 here by just clicking and dragging on the right, and then I'll right click and say delete. And just get rid of those rows. Now what I need to do is make sure that the names of my attribute columns are cleaned up. So GIS is really picky here. We need to make sure that we do not have any spaces or special characters except an underscore in any of the names of our attribute headers here. So take a look at the data and start pointing out any particular problems. So anything you notice, just go ahead. And take a look. So again, I've gone to where I've downloaded the data. If you're working remotely, for me, it's my D-Data2 drive to this working with Tabular Data folder. And I've opened the spreadsheet TRI Facilities 2014 raw. You've downloaded the geocoding data. We'll take a look at that later. We don't need to do anything with it yet, but go ahead and open that TRI Facilities 2014 raw spreadsheet in Excel. So what sort of problems do you notice? What do we need to clean up in our data? No, we can only have the underscore character. So anything else we need to remove. So do you see a hyphen? Yep. So we have FAC ID. I'm going to change that to FAC underscore ID. Last year, yep, in column K, last hyphen year, let's change that to an underscore. What else?
There's an asterisk and other amount.
An asterisk before other amount. So all the way over in column W, we'll remove that. Any other problems? Nope. I'll read through. Looks okay to me. The next thing we need to check for is that our field names have less than 255 characters. I think we're okay there. For this particular address locator we're going to use, it requires this the address, city, state, and zip code to all be in different columns. So it's going to read each of those from a different column. So do we need to split any of our columns? Sam's shaking his head no. Right, so we have our address here, 1460 Columbia Nitrogen Drive. That's a cool sounding road. I have a city, column, a state, and a zip code. So we look okay there. Some other things you want to look out for are reserved words. There are specific words that the Microsoft Access database format that ArcGIS uses does not like you to have as the names of attributes. Things like date, time, year, what are some other examples? Value and text. These are things we don't want to have as the names of attributes. So do you see any of those? Our year column is called last year. We're all right there. I don't see a time or a date or value.
What's going on with some of the zip codes?
What do they look like to you? So the zip code, oh, I see, wait, sorry. So our zip codes, if I expand that field, you'll see some of them are 9-digit formats.
Okay.
So the column width was choosing to display them in scientific notation.
Okay, it says last year.
Yep, so last underscore year is okay. We wouldn't want to use the word year by itself, but last underscore year is okay.
You said text was one of the words?
Right. Text is not a good word to use. Does it look okay? Feeling pretty good about it? We'll put it to the test then. So let's file and save a copy. So let's go to File, bless you, Save As. We'll save it in our same directory, that D drive, working with tabular data. But here I'm going to change the underscore raw to underscore clean. So it says TRI Facilities 2014. And I'll continue to save it as a CSV file. And then click on Save. Click Save again. Whoops. Nope. I don't want to save it and overwrite. I want to call it clean. Save. Everybody, you have a new version saved? Once you've got that, you can close Excel and then open ArcMap. So I'll go to my Start menu, to All Programs, find my ArcGIS folder, and open ArcMap 10.5.1. I'll close Excel. If you work a lot in Excel and GIS at the same time, what you'll run into is that both programs like to lock your data while it's open to prevent it from being corrupted by another program. So it will be a little bit frustrating because you'll have to close Excel to open the table in GIS and vice versa. So make sure you've closed that data table once it's saved in Excel. Okay, so as ArcMap opens, I can close my Business Analyst Desktop Message Center. And here I have my ArcMap window open. So now that we have ArcMap open, what do we normally need to do first? Yeah, we need to connect to a folder. So we need to set up 2 folder connections. The first to all of our data for today, and then also that network drive that has our street locator in, our address locator. So I'll open my catalog panel if it's not already pinned, and I like to click that push pin to keep it open. I'll right click on my folder connections and say connect to folder. And I'll first go to my computer, expand on the word computer, then click on that data to D drive, so the hard drive on these machines, and go to my working with tabular data folder. For the remote people, this will be the location you've extracted all of the data to on your machines. So I'll just connect to that folder D, working with tabular data, and then click OK. And the next thing I'll do is start that second folder connection. So I'll right click, connect to folder again. I'm going to go back to computer, but now click on this GIS drive near the bottom of the list, that libstorage.clemson.edu. So I go down my list here, near the bottom is GIS. I'll expand that folder, go to my Geocoding Data 2014 folder, expand that, and then click on Geocoding Data. Sure. So do you have the catalog open on the right? We'll right click our folder connections, click on connect to folder, go to computer, click on GIS near the bottom of the list, click on Geocoding Data 2014, and then click on the Geocoding Data folder, and then click OK. And then I also connected to the D drive and working with tabular data folder. So go ahead and expand that Geocoding Data folder over in our catalog.
Can you take a step on?
Sorry?
Next folder, the last step.
So connecting to this one? Sure. So from folder connections, right click on folder connections, click connect to folder. Went to computer. Down near the bottom is GIS. Click on Geocoding Data 2014. And then click on the Geocoding Data folder within it. And then click OK. So what do you see there in the ARC catalog in our Geocoding Data folder? Little houses, yeah, right? So again, our GIS software is interpreting those files we saw before, those 3 of them, which together make up one address locator. So again, we have different styles. We have one that will geocode zip codes, one that will take a city and state. We're going to use this one called street_addresses. Let's also expand our working with tabular data folder connection. And so you should see your TRI facilities 2014 clean.csv table that you saved just a minute ago. So from my working with tabular data folder connection, I've saved this TRI facilities 2014 clean. I'm going to drag and drop it into ArcMap. And then I'll notice, again, my table of contents over here changes its style to this option list by source. Because it can't draw a table, there's no geographic information. It's just going to show us the source or its path on the machine. But I can right click on that table on my TRI Facilities 2014 and then click Open and view it just like any other table. And so I want to go through and make sure that all of my data made it. So does everything look okay here?
Yeah.
Sure. So everybody's got their table open. Does it look okay? All right, so let's take this table and geocode it. We're going to add the geocoding toolbar, just like any other task you might need to do in GIS. There's probably a specialized toolbar for it. So how did I add those to ArcMap? Customize. Sure. Customize menu at the top, toolbars, and then we're looking for geocoding. Here's my geocoding toolbar. Here on the left, in this first dropdown, you'll see that those words, Esri World Geocoder. This is where you select an address locator. If you click the dropdown, you'll see also this MGRS and the USA Local Composite. These are just defaults in the software. This Esri World Geocoder, again, is going to consume credits on your account. So it will require you to sign in to ArcMap to use it and then use credits from your account. We're going to add this street addresses locator. So if I go over to my folder connections, to that geocoding data folder, I can drag and drop street addresses into the map. And now we'll see that name street addresses show up. That's the geocoder, the locator I want to use. And so for those of you watching remotely, should have already extracted the street address geocoding data that was within your working with tabular data folder, and you can drag and drop it from that folder. Is everybody with me right now? Does anybody need to see anything again? So this second button right here on my geocoding toolbar is this mailbox. That's my geocode addresses tool. Go ahead and click on that. It's going to ask you once again. It's going to ask you which locator you want to use. We'll select street addresses and click OK. And we get our dialog here. It's going to ask you, where's your table that you want to geocode? And so we only have one table in our document. It's going to read in our TRI facilities. For our input fields, we need to match each of these parameters specific to our address locator, our street, our city, our state, and our zip, to a field within that table. So again, the software is pretty smart that we've seen it will guess, and it did a pretty good job. So we know our addresses are Our street or intersection is contained within that address column. Our city is in our city, state, and zip, and so on. We need to specify an output, and this can be either as a shapefile or a feature class. So we'll save this as a geodatabase feature class. I'll click this browse icon at the end, and we're going to navigate through our folder connections to our Working with Tabular Data folder, to the TRI Facilities 2014 Geodatabase. So again, I went at the top, look in to D, Working with Tabular Data, double click on my TRI Facilities 2014 Geodatabase, and we'll remove that name Geocoding Result because that's a terrible name for a data set. I'll call this TRI underscore Facilities underscore 2014. Click Save. The next thing I want to do is click on this Advanced Geocoding Options button. So here's where you can really dive in and start customizing how the flexibility of your locating. So these three options here: spelling sensitivity, candidates, and match scores. The higher you set these, the pickier your locator is going to be. So we want this to match as many addresses as possible. That's our goal today. So for this demo, we're going to turn our spelling sensitivity down to 10. So we'll be very accepting of misspellings. We'll leave our minimum candidate score at 10, which means it needs at least a 10 out of 100 to consider it a candidate. And we'll set our minimum match score to 10. The minimum match score we set to 10. So I put a 10 in for those first three values. Yep, so go into the geodatabase, double click on the geodatabase, go into it. Yeah, so you can go into the geodatabase, it's like a folder. And then I click on Geocoding options. All right, I'll go ahead and click OK right now to accept these results or these parameters. And then if you filled out the rest of this, like I have, click OK, but don't close the window that comes up with the results. Just leave that open. So I'm going to click OK, and it's going to match, and then just leave this open. So what percentage of these did our geocoder match right away? 88%. So 438 out of, I don't know, about 500 records. It found a match within our data. And then it found 25 or 5% of them had a tie. It couldn't decide between two equal candidates. And then 37 or 7% of them, it just couldn't match at all. So it didn't find something within our database, our reference data, that could match. So what we want to do is click on this Rematch button to actually go in and manually locate these points on our map.
What are you kind of matching?
So we're using Esri street data. So it's a database from Esri that has streets and addresses on those streets. Yep. So you can see on the map a whole bunch of points that showed up. And here we have our interactive rematching window. Let's also add a base map to our map. So I'll go to my Add Data button next to the scale, click that drop down, and click on Add Base Map. And we're going to add the streets base map layer, which is actually very similar to the streets data we're using as our reference. So here we can see something we expected before, right? Most of our points were here in South Carolina, and then a few in North Carolina and Georgia adjacent. So I'm going to drag and maximize my interactive rematch window here. So here at the top, under Show Results, it's showing me all of my unmatched addresses. So within this table are all these different points that it could not locate, right? There were 37 of them. This first one that's highlighted had the address 12 Ed Needham Drive, Mansfield, Georgia 30055. So it could not find that in my streets data. So what we want to do is pick it from the map. So if we have other information available about where this might be located, we can go and manually assign it to a location. So first, I went to Google Maps and I typed 12 Ed Needham Drive, Mansfield, Georgia 30055. And what I found was it was located right here near the intersection of Highway 213 and 11 in Mansfield, Georgia. So I can see within the town where it was actually located.
Why couldn't ArcMap locate it if Google Maps could?
Yep, why couldn't it find it? Let's take a look. I'm going to minimize, not close, but minimize my interactive rematch window. And then I'm going to zoom in on my map to Mansfield, Georgia. I'll close my table here and try zooming into Mansfield. So I know it's somewhere along I-20 west of Atlanta, east of Atlanta rather. So I'll start zooming into that general area. It is, where is Covington? Here it is, or Mansfield. Where is Mansfield?
Southeast of Covington.
Southeast of Covington, thank you. Here we go. So Covington has a few points within it. As I zoom in, I see Mansfield more and more to the southeast. And then as I zoom in further and further, I have something fairly similar to what I'm looking at in Google Maps here. So I will zoom all the way out again, just for those of you who are having a hard time finding it. So we're looking east of Atlanta along our main highway here. And I'll keep zooming in. I see Covington, it's southeast of Covington. I find that Highway 11, here's Mansfield. And I'll zoom in until I have a view pretty much like this. And now I'm going to open my interactive rematch window again. So I'll go down to my lower left corner and maximize my window. And there's this option to pick an address from the map near the lower left corner. Pick address from map. So I'll click on that. I'll move my interactive rematch window. And now notice my cursor has this tiny blue circle. And as I click and hold the mouse, it will show me a street or intersection data. And so if I try to locate from Google where I see 12 Ed Needham Drive, it's just off Main Street and south of this Highway 213. It's right about here. What do you see in the address bar as I click and move my mouse around?
On Pine Street.
It thinks this road is called Pine Street. Exactly. So our reference data, this Esri Streets data from 2014, have in their database that this is Pine Street. So when we went and looked up Ed Needham Drive, it didn't know where to put it because at some point in the last few years, they've probably renamed it. And so we were looking at a static data set here in ArcMap. Google somehow found a more updated name for that street, Ed Needham Drive. So what I'll do is, again, try to find an approximate location for something that matches that 12 Ed Needham Drive. So I see, this is all South Pine Street, something around 20 Pine Street. So now I'm going to use that 20 Pine Street, go back to my interactive rematch dialog here. And here on the left where it says street or address, and I had 12 Needham Drive, I'll try 12 Pine Street, Mansfield, Georgia. And then click search in this lower right corner down here.
Could I use the blue circle? I just see South Pine Street.
Yeah, so if you move a bit further to the south, it showed some numbers. So we'll just try changing Ed Needham Drive to Pine Street and then click search. And so when you click search, it's going to show you all of those candidates with all of their various scores. So at the top of our 12 candidates, it found 12 Pine Street right away and gave it a score of 100. There's 12 North Pine Street that had scores of about 90 and then going down. But we want to use this first one, 12 Pine Street. Is everybody there? Once you have that, go ahead and click on this first row and then click match in the lower right corner. And so that will put that match address here in that blue highlighted column at the top. So now we've taken that unmatched row and we've matched it to a location.
So I picked that address on the map and not getting any data on my TRI facilities.
So I went through and then I changed Ed Needham Drive to Pine Street over here in the street, and then clicked on search in the lower right-hand corner. And then you'll see all of the candidates. And then I selected the first candidate with a score of 100 and then clicked on match. So the rest of today's workshop, we'll just go and try to find all the other 36 that we didn't match. Sound good? You're all looking at me like, is he kidding right now? No, so it is a labor-intensive process, as you can see. And so this will highlight to you the importance of having good reference material and a good street or address locator to match your input to your reference material. So I think it's pretty great that we got 93% of our data matched to something right away. And within maybe an hour or two of work, we could finish our data.
Is it safe to assume that the matches are actual matches? Correct.
Is it safe to assume? I would go back and run it with higher parameters than we did before, because we lowered our spelling, we lowered the minimum match. I would run it with higher parameters, but the data, the source data, were very good for 2014. So they're a high quality data set that we've made available to you. It's just that somewhere in those past 3 years, something changed. I guess 4 years. So we could go through and match all of these, but we will just click close to close our interactive window here. And now notice in my table of contents, here's my geocoding result at TRI facilities. I'll right click on it and select zoom to layer just to see that extent. And I'll switch over my table of contents from list by source to list by drawing order. So scale of 1 to 10, how hard was this compared to anything else you've done? 6? It's a little more involved. So first we needed to obtain some data, and then we needed to clean it. So we got data that were fairly clean to begin with. Depending on your source, that may be the case, or it may not. So we give a workshop on Open Refine, which is a really powerful application for cleaning tabular data, say standardizing the formatting, reducing duplicates, and all sorts of advanced data cleaning functions. Then we had to grab our address, our database of addresses and our address locator, and then go through this process. So it is a little more involved, but still we took a table of information, and here in just a few minutes we've created a geospatial data set that we're going to use for the rest of our time here. So just to review from last week, how did we add data to the map? Who wants to show us, who wants to try and add data to the map using latitude and longitude? Need a volunteer from the audience. Who's it going to be? Volunteer.
What's the task?
We're going to, who can show us how we took a table like our TRI facilities and use that latitude, longitude information we have and turn that into a data set? Who remembers how to do it? We'll narrow it down. Storm, thanks for raising your hand and volunteering to do this for us. So why don't you come on up? So if the geocoding didn't work for you, we'll add these data as latitude, longitude, and export them so you're still able to query them later on. So go ahead and follow these steps for those of you watching remotely. So we'll add our TRI facilities 2014 clean as latitude, longitude. Go ahead, Storm. What are we going to do? Walk us through it.
All right. Get our thing here.
So Storm has switched over to the list by source view in the table of contents to show that table.
Then you right-click your table, display XY data.
Yeah, display XY data, right? So here we're going to add this events data set layer. It's going to use some sort of coordinate information.
Make sure your X and your Y fields are properly selected.
Yeah, Yeah, so it's read in longitude for our X, latitude for our Y. Looks good. We need to specify the geographic coordinate system that the data are in.
Do you go to edit?
Yep, so we'll click on edit. Can you show us from the top
Yeah.
where we are?
If you go all the way up, we're in geographic coordinate systems.
Yep.
Is there a certain one you want? Just
They're
based on-
WGS 1984.
so you can either
What do you do when the spatial reference properties? Okay, I'm sorry.
oh, you're fine. You can either find it through the geographic folder path, or you can go to your layers, which shows you the already used coordinate systems.
Is it in there? Oh,
Yeah.
it is. All right. So we found that GCS WGS 1984. That is our geographic coordinate system. Click OK.
Click OK again.
Click OK again. Yep. All right. We've got it. Thank you, Storm.
Welcome.
Let's give him a hand. So here we have our events layer. And what do you notice in the map already as you compare this data set that we just added with latitude, longitude? It shows up as blue dots compared to my geocoding result, which are these green dots. On my
Not
map.
quite the same.
They're not.
Offset.
They're not quite the same. A lot of them overlap directly, but some of these put us on a slightly different location in the map. So here the geocoding, again, we're taking some description of a location and searching through a database and trying to match it to something in that database. So if we don't get a good match, or there's not good information in our database, we might not locate it as precisely as if we just have a coordinate. So let's export that events data layer to a feature class so we can work with it. So I'll go over to my table of contents, the TRI Facilities 2014 events layer. Go down to data and then click on export data. So again, I right click my events layer, go down to data.
The data, the one that looks like a data.
It's the one with events after it. So our events layer, go down to data and export data. And we'll just use the same coordinate system as the source for now. My output feature class, I will browse. Click that folder to browse. I'll click at the top, look in my folder connections in my working with tabular data folder. And I'll save this in my TRI Facilities 2014 geodatabase. So I'll double click to go into that. I'll show it again in just a second. So I'll save this as my TRI underscore facilities underscore 2014. And I'll call it underscore XY. Since I created these slightly differently. And then click OK. And I will add it to the map as a new layer. So do you have the events layer? Okay. I'll pause. I added X, Y to the end. On our table, and then we're going to display X, Y table. So we did longitude and latitude. Works.
Okay, so I have the events there. I'm not seeing.
I'll show you that.
Okay.
But since you already had the export data to the
Yes.
Yeah, we're saying yeah. As long as you export it as a new it's just.
Okay. So once we've created that events layer, I'll right-click its name in the table of contents. So right-click that layer with the word events, go down to data, click on export data. And then I clicked my folder icon here to save it in a new location. I'll browse, clicked in look in, selected my working with tabular data folder. Double click my TRI Facilities 2014 geodatabase. And I saved it as TRI Facilities 2014 XY using underscores, no spaces. And then you can add it to the map as a layer.
So why do we have to go through all these steps again? I mean, I know the steps, but what was the logic behind that?
One was just a review from last week
Okay.
to see if anything stuck and just refresh. And then two, to compare adding data as latitude, longitude coordinates to the result of geocoding.
And that was a way for us to get some of those X's to show up.
Right. And really just compare the two processes.
Okay.
Yep. Any other questions?
Instead of like trying to find new addresses, why didn't we just keep our platforms, you know, and see what I'm doing?
So imagine we didn't have coordinates for them. This data set is nice because it gives you both, but geocoding is better or is used when you don't have that coordinate system information. All you have is a description. So here our data set had latitude, longitude. Let's review something from last week and then compare the two operations. Yep, any other questions? Okay. So we have gone through, we've geocoded some data. The next thing we're going to do is dive into those attributes. We'll open the attribute table and learn how to query or make queries against the database. So this is a very common operation, but it is very powerful because it allows you to identify features in your data that meet some set of criteria. In ArcMap, most of the geoprocessing tools will work on a subset of your data, your selected data, if you have a selection. So you can find parts of your data set that meet some criteria and run an analysis only on those points. That's another really common operation here. So ArcGIS is built around this SQL, or structured query language. And so the most common operation, or what we'll look at, is this selection, which it's a statement where we're going to select from a table being our data set, then we have our SQL statement. Field equals a value, or is less than a value, or greater than, or something even more complicated. And then it will take that statement and test every record in your data set. And if that statement is true, then it will select that record. And so identify all these elements and return this subset of data. So you can do fairly simple things like find those that have an area greater than 20 And you can do more complicated statements. You can nest statements, use all sorts of logical operators and combination. So here we're going to identify things where the area is between 20 and 50, but not including 20 or 50, right? So find those elements where the area is greater than 20 and those less than 50. So the basic operations here are these standard set algebra. We have things like an equal to, greater than, less than, or not equal to. And you can do these sorts of operations on numbers as well as on text. So if you're looking for a name equal to or not equal to, or some set of characters that are equal, you can search for those things. There's also Boolean operations, right? So you can identify things that not and or, where not is going to return the opposite of what you have searched for. So states not South Carolina would return 49 states, every state but South Carolina, and requires 2 statements to be true in order to select that item. And then you have or, which is more flexible. As long as one of these conditions is true, it will select that item. And so you can use parentheses to build an order of operations in your selection, just like you could in an algebraic statement. So here's a visual representation of that Boolean algebra. Here we have our regions A, B, and C. And we'll work our way clockwise around. So A or B, right? If I have these 3 overlapping circular regions, A, B, and C, A or B means it would select any part of these 3 that falls within A or within B. So what would that look like? If you were going to shade it in, which sections on the diagram would be shaded? All these components that make up A and B. So right, it's A or in B. Yep. So any of these locations would be returned. How about A and B? Right, just this part where A and B overlap. How about A not B? What's that going to look like?
Only A.
Only in
A minus the part.
A minus the part that overlaps with B. So just this section, right? Yep. Now we can combine these statements. So A and B or C. What would that look like?
The intersection part of A and B including the C.
Could you say it again?
The intersection part of A and B including the C cell.
Right. So we have the intersection of A and B and the entire portion of, whoops, got ahead of myself here. We'll come back. You had that one right. So I was a little out of order. So this not statement is going to operate last because here we have parentheses that says A or B, which is our section here at the top left, and then do a not on that entire region. So it would take this and then select everything not within A or B. Easy enough, right? So let's do a couple examples then. Here's our data table that we're looking at. We have some IDs. We have an area, some numeric value of area. We have a land use category, and then also a municipality category, whether it's in a city, county, or township. So how many of these records have an area greater than 20? How many records would be selected when we run that query? How many? 4. Yep. So ID 2, 4, 5, and 6 all have areas greater than 20, and we'd be returned. Find all urban land use. How many would we be returning? 3. Yep, IDs 1, 5, and 7. So our third one, find all records with area less than or equal to 55. Five. Yep. So what kind of statement is our last example? A not statement. So really what we're going to evaluate first is what are those that are urban land use, and then take a not operation. So here's urban, urban, urban. And if I do a not, that's going to leave 4 of them behind. So our actual statements that we've been typing in are shown here. We could do a land use that does not equal urban, or also use a not statement. So compound queries. Here we want to find municipalities that are not urban cities. So what would that statement end up looking like? If we want to query and find municipalities that are not urban cities, what's that statement going to be? Urban and city. So urban and parentheses, or urban and
Not parentheses, urban and cities.
not parentheses, urban and cities. This, is that what you're saying? Okay, so we would be identifying all of those that are land use that is urban and municipality equals city, and then taking the not. Bingo. All right. So we'll evaluate that first set of and then not after it. Is this stuff making sense? Any questions so far? So it's really just writing a logical statement where you can identify the criteria you need. I think I have a lot more examples here. We'll cruise through them and just show you some of the other types of statements you can use. There is an in. The in works like nested or statements. So rather than printing or a bunch of times, you can specify an in with a few values. So here we'd be looking at state, and rather than saying find where state equals Alabama, or state equals Alaska, or state equals California, or state equals Florida, we can just use one statement in and then list these parameters or these entries. The like command is a wildcard search. So you can specify parts of strings using either percent signs or a shapefile or asterisks for a geodatabase table. And so you can represent multiple characters or end or partial string searches, right? So we can go and identify things where we don't know the entire value. So let's say we're looking up a name and we don't remember if it was Larry, Barry, Harry, Terry, Carrie, right? We would set up this wildcard here where we can wildcard in that first single character to find those using either an underscore or a question mark, depending on whether it's a shapefile or geodatabase. Or we can search within a string. So if we know the place name has an ort in it, we can use either a percent sign or an asterisk on both sides of that string and then search anywhere within an entry. Questions on any of these?
What does SQL mean?
Structured query language is the name for the language that's used. Any others? So what this tool looks like when you actually perform a query is a dialog where you have a layer drop down. You'll select a layer. There's a method where you can create a new selection. You can add to or remove things from that selection. And you can also select from currently selected elements. So the add to works a lot like an or. The remove from is essentially a not. The next thing you do is use this interface where you can double click or click on things to build your statement rather than typing them in. So if I'm interested in finding this LU code attribute, say our land use code, that's equal to 22, rather than typing all of that in, I can just double click on my field name, click my equals button, and then go and read from the values on the right to build that statement. And so this is very nice because you don't have to worry about things like spelling mistakes, extra characters, spaces, whatever getting in the way. So you build your statement, you apply it, and it will return that subset to you. Oops, keep going ahead of myself. So let's go ahead and try this. Let's go back to ArcMap. Actually, a lot of you look like you need to run upstairs to Starbucks and grab a coffee. So let's pause for the next 12 minutes. We'll come back at 40 after. Feel free to grab a coffee, stretch your legs, do some jumping jacks. We'll come back in a minute. All right, still waiting on one more, but let's clean up our map document as we get back into this. So we can close our geocoding toolbar. We're done using that for today. We can close that. I'm going to switch back to my list by drawing order in my table of contents. This icon in my upper left corner, list by drawing order. And I'm just going to remove a few of these layers. I don't need that TRI Facilities events layer anymore. So I'll right click on that and then click remove. I don't need my business analyst network barriers. I'll right click those, click remove. We can leave our geocoding result. I'll just turn that off in the map for now. We'll work with our TRI Facilities XY data. And I'm going to open that attribute table for it and keep that open. So I'll right click my TRI Facilities 2014 XY in my table of contents and click on Open Attribute Table. And I also like to keep my table docked here on the bottom of the screen so I can click and drag and drop it on this blue guide at the bottom. So we're going to make all sorts of queries against this data set to subset and select different elements and learn how we use our selection tools here. So the first thing we're going to do is just look up and identify all those facilities located in the state of South Carolina. So if you look at those attributes, look in that table and think about what we were just talking about. Like what would our statement look like? What do we want to use to identify those facilities located in South Carolina? We'll use an equal sign. Yep. So if we look through our attributes, we're going to identify those. Which attributes are we going to use? State equals SC. Yep. So if I go over to my, whoops, didn't mean to undock that. Go to my state column here. I'm going to right click on it, click sort ascending, and I'll notice I have state GA, NC, and SC. So my original data set had Georgia, North Carolina, and South Carolina. So I just want to identify those rows or those points where that state equals SC. So what I want to do is first, let's go to the selection menu here at the top. Along the top of ArcMap, selection, and then we're going to click select by attributes. And that's going to open that dialog we saw before. And here I see that statement again. I'm going to select from TRI Facilities where, and my statement will go in this box down here. Select by attributes. Yep. We'll do select by location next week. So we want TRI Facilities 2014 XY as the layer here on the top. We want to select items from that layer. So you can go in the drop down and see you can select from all the layers in the map. We'll select TRI Facilities 2014. Our method, we want to create a new selection. which is the default. And from here, we don't have to type anything else. We can just click to build our statement. So within this list are all the attribute fields here within the table. What I want to do to start is find the state. And I'll double click on that. And then notice it shows up automatically down here in my box. And we said we want equals. So I'll click once on the equals sign. And then I need to click this Get Unique Values button. And that will scan through that attribute column and show me every unique entry within it. So here I have GANCSC. Right, so notice that it has these single quotes around it, which means it's a text or a string of characters. But now if I double click on SC, then it will automatically fill that here in my statement. So state equals SC. A very, very useful option is this verify button. So if we click verify, this will read through and make sure that your syntax is correct. So if there are any spelling errors or any other issues, it will tell you that there's a problem. It will also tell you if there are no records that meet your statement. So it also passes that as a warning. So our expression was successfully verified. I'll click OK, and then click Apply. And when I do that, it's going to highlight all of those locations in blue. So here I see in my map, all of these points show up with this bright blue selection color. And then it also tells me here in my attribute table near the bottom left corner, it's selected 267 out of all 500. So there are 267 features that were selected. If I go back to my attribute table, right click my state column and click on sort descending, so that SC, South Carolina, is labeled first. I notice here in my table, all of these rows are also highlighted in blue, which indicates that they're currently selected. If I want to look just at my selected features, here in the bottom left corner next to that letter 267, or number rather, is this show selected records. If I click on that, it will only show me elements that have been selected. So as I go back and forth, I can view all of my entries or just my selected entries. Easy enough, right? So are there anything you can think of right away you might want to do with these data?
I want to click on a dot on the map and see.
Yep. So we could click more information about it. Remember I said any geoprocessing, we haven't done much yet, but keep this in mind as we go. Any geoprocessing tool I run, or most of them, would only run on this subset of my data. Or if I wanted to copy and export a new data set with just the facilities in South Carolina, if I go back to we don't need to go through these steps, but if I right click my layer, go to data and export data to a new feature class, which I will do quickly just to demonstrate. These are my TRI facilities in SC, click save, click OK, add it to the map. There are only 267 records, right? So now it's saving and exporting just those selected features. So that's also a really common thing I've done hundreds of times, is just export a subset of my data based on a selection. Let's close our Select by Attributes window here. Click the X at the top, and then go to the Selection menu, and then click on Clear Selected Features. So notice in my attribute table, when I click this, I'm viewing only the selected features right now. When I clear them, they all go away. But I switch back to my other view, and they're all 500 facilities. Another really neat feature that builds off of a selection is called a definition query. And this is basically a filter you can apply to your data where it will only display features in the map that meet that search query. And it will hide all of the other features without removing them from your data set. So let's say we only wanted to show facilities in South Carolina in the map, but we didn't want to delete them out of our data set or export a new one. We're going to set up a definition query that will do just that. So let's right-click our TRI Facilities 2014 XY layer in the table of contents and open the layer properties down near the bottom of that list. So for my layer properties dialog, I'm going to go to the definition query tab. And here's a box where you can set up a query. You could type it in, or we'll click on this query builder. And then we'll see this very familiar dialog now. Right, so if we wanted to restrict these just to South Carolina, I can apply that same query. Right, I'll double click on state, click once on equals, click on get unique values, and then double click on SC. And once again, I'll click verify just to make sure I didn't put any errors in here. It says it was successfully verified, so I'll click OK, and then I'll click OK again, and then apply. And now I notice in my map, it's restricted the view, so it's only displaying those 267 records, and only 267 show up in my attribute table as well. So this is really useful if you want to just show some subset of your data in the map without removing any other information. From my definition query dialog here, I can delete that statement. So I'll highlight my state equals SC in my definition query, click apply, and then all of my points come back. And then I'll click OK again. All right, the next type of selection we want to do, let's start doing some more complicated statements. So our goal here is, let's say that for my research, I just want to work with and identify facilities in South Carolina where either the highest or second highest chemicals released by mass were toluene. So I'm interested in toluene releasing facilities, and I want to identify just those facilities. So if you look at the attribute table, take a look at all of the different fields, all of the different attributes, and let's write our statement. What is our selection statement going to be? So I'm going to rely on all of you. What would that look like? So we're looking for toluene, T-O-L-U-E-N. Yep. So what type of statement are we looking for? Do we want an and? Do we want a not? Do we want or? Or, what you just said, yep. So I said I'm interested in those where the first two contaminants that they've listed would be toluene. So just those primary toluene releasers. So what fields do we have in our table? We've got Chem 1 amount, Chem 2 amount, all the way down to Chem 5.
Chem 1 and Chem 2 equals, what do you have for that? So
So we'll have parentheses in here, yep. So we'll have some parentheses. And we said
Kim 1 and Kim 2.
Chem 1 equals volume and Chem 2 equals volume.
I'm not, are you looking for facilities where both where both of them are toluene, or if it's one or the other? Because if it's one or the other, wouldn't that be more?
Right, so in this case, it could be one or the other. They're not going to have the same chemical listed in both of these. So we don't want an and, we're going to use an or in between. So where chemical 1 equals toluene or chemical 2 equals toluene. With the parentheses around that statement. Awesome. Let's give that a shot. So if I have my attributes table open, I can also select by attributes by clicking this button in the upper left corner. This little select by attributes. So if I click here, I get the same window. So we're going to create a new selection from TRI Facilities 2014 where Chem 1 equals, so I'll double click Chem 1, click equals, and I'll click get unique values. And there's a long, long list of possibilities. Near the bottom is toluene, T-O-L-U-E-N-E. I will double click that. And then click or, whoops, didn't mean to click it twice. Or, and then double click on Chem 2 equals, and then get unique values. And then scroll down till I find toluene once again. Double click toluene. And then I'll verify my statement. So I'll click verify. It says the expression was successfully verified. Good. So I click OK, click apply. And how many facilities do you get? 48. Me too. All right. So this is giving us all those facilities where Chem 1 or Chem 2 is toluene. If I wanted those to be just from South Carolina, how would I amend this statement?
You would you keep the parentheses, and then you put and parentheses state equals South Carolina parentheses.
So we'll continue on below and
Did you need parentheses between state and South Carolina?
no, we don't need parentheses on this because it's only one statement. Or we could write it here at the beginning as well. The state equals C and all of that. So let's add that portion. So I'll click here after the word toluene. In my box, click and find state. Double click state. Click equals. Click on get unique values. Double click SC. Verify. It was good. So how many facilities were located in Georgia or South Carolina?
South Carolina is 21.
So I get 39. It was 48 before.
Oh, I didn't do Georgia, I'm sorry.
Oh,
I did
yeah.
South Carolina.
So I'm sorry, I might have phrased that strangely. We had lost 9 facilities when we did that. So there were 9 located in Georgia or North Carolina. We could check that by amending our statement. Remove state equals, type state in parentheses, Georgia NC. Oops. I think I forgot a space. And a comma.
When would you need to use parentheses?
So parentheses are going to group statements. So anytime you're combining things with or, not, and, those will require a parenthesis.
Because I took it first with parentheses, and that's what gave me the 20. And then when I took the parentheses out, without changing anything else,
So you ran it first,
first with what was on the board.
the whole thing here?
Yeah,
State equals SE and Chem1 equals Tally before this.
yeah, and that gave me 21. And then when I got the parentheses, that gave me.
So what you had, state equals SC and Chem1 equals toluene or Chem2 equals toluene.
So does that mean that the order of operations is like and first and then?
So here we would just be reading left to right, just like a normal statement. So first we're evaluating this and state is SE and Chem1 equals toluene, or any facility where Chem1 is or Chem2 is toluene. So yes, the parentheses were very important in making that distinction between the two.
I can't read that. Thing goes so far our way. What is it again?
It's just a statement on the board. But
So we should only have 21.
yep. So this is great. It shows you the importance of using parentheses to get the results you want. But we can close our selection window and clear our selection from our table. Here at the top is this clear selection dialog. You can click that to clear it out. Let's try a wildcard search. So let's say I know there's a facility and it's in a city that has Boro in it, B-O-R-O, but I can't remember what that city was. Let's see if we can find and narrow it down. So we're going to open our Select by Attributes window. We can go to our box and remove any of our last search here. So we're going to use a wildcard and say city, double click the city, click like, and here we're going to type. And so it needs to be just like I have. So after the word like, type a space, a single quote, %, Boro, whoops, with all capital letters, and another single quote. And then verify the expression. So once you verified it and typed it in, go ahead and click apply. And what are our options?
There's nothing. Wait, this is city like Boro, B-O-R-O.
Yep, city like Boro, but we need to have after like a space, single quote, %, capital B-O-R-O, single quote. So I think I heard a lot of you say 12. So I found 12 as well. What are they? We have Walterboro, Winnsboro, Mooresboro, Roseboro, Wadesboro, Toomsboro, Tomsboro, Greensboro, Swainsboro, Waynesboro. So even that didn't help me because those are all sound the same in my mind. But here we have our wildcard, so we can search through and find any of these. Was it looking all the way through the attribute? Was it looking at every part of it? Or was this one more specific?
This is where it borrows.
Just where it borrows at the end, right? So we had a percent sign before the letters borrow, but not after, which means the beginning of this statement could be anything as long as it ends in BORO. So if I put a percent sign after the O and before my single quote, I'll verify just to make sure it's successfully verified. I'll click apply. I get the same thing. So there isn't like a Borosberg or anything like that in our data. I'll clear my statement. And I'm going to try it one more time, but I'm going to use lowercase letters. I'll type or click on city, like, space, single quote, percent sign, Boro, single quote, and then apply. I noticed that it didn't return anything at all. So these are case sensitive. So lowercase b-o-r-o is not exactly the same as capital B-O-R-O in the eyes of our SQL dialog here. All right, so I'll clear my statement. Do you want another quick practice one? I'll test you on it. Facilities in South Carolina or North Carolina whose first, second, or third chemicals released were toluene and the mass was greater than 10,000 pounds. And tell me how many you come up with. Yep. Facilities in South Carolina or North Carolina where the first, second, or third chemicals listed are toluene and the mass is greater than 10,000 pounds. 10,000, greater than or equal to 10,000 pounds.
So you said mass first. I don't see.
Where's what?
You said mass greater than 2,000. I don't find the attribute. What is that?
How many facilities are there in North and South Carolina that have either of those three chemicals? 50. Yep. And the masses are contained within those Chem 1, 2, and 3 amounts. I'll let you keep working at those. I will continue on since we're running low on time though. And talk about our next operation that we'll explore. So joining data. Here's our last topic for today. So joins are a way we can expand on tables. We can bring in new information to existing tables. So here in my my pictures, if you have, say, boring geometry, let's say you just have counties in Oregon with no other information, but you have a table that has statistics about it, boring old population and demographic statistics. You can append or add all of the statistic information to these polygons, and then you can start to do cool things like mapping those features. Right, so this is a way you can extend or improve or expand your data by bringing in new information. So what this does is it's going to look through two tables to find some field in common, some record that links one row in a table to another row. And then it will just add on those attributes to the end of the first table. So oftentimes what you find are out in the world these polygons that just represent a geographic location, but don't have any data associated with them. You may find a database where you can download tables that have information about each country, each state, each county, each zip code, whatever, but you want to map those things. You don't have those polygons. This is a way of combining the two data sets together. Is through our joins. So when we join our fields together, we're going to use this common key field between the two. And so this needs to be representing the same thing. So you don't want to link, say, a land use code here at my bottom with an object ID. They may have the same entry in there, but they don't represent the same thing. So you want to make sure that conceptually your join makes sense. But then it's going to look through the entries of those fields, and wherever it finds a matching entry in the two tables, it will bring the two together, as you see here on the bottom. So our input for this example is we're using this land use code in two different tables that has values from 0 to 2, and those values 0 to 2 represent a specific land use type. So my original data set just has those codes. My new table tells me what those numbers mean. I can join the two using this land use code as my key field to bring it all together. What's really important is that the type of field is the same between the two. So you remember when we created fields last week, we specified them as either text or as integers. Everybody remember that? So a text containing the number 1 is not the same thing as an integer 1. So the fields need to be the same type. You can match text to text and numbers to numbers, but the two would not join each other. The join is dynamic. So what that means is it lives just in that map document unless you export the data after the join, and then it will preserve and export all that new attribute information. Make sense? All right. So joining, whether you can do it or not, is a function of the cardinality between the two data sets. And so there are a couple of terms that we're going to refer to here between our tables. Table A on the left is our destination table. This is our existing data set. Table B is our source table. This is our source of new data that we're going to join and try to match to features in table A or our destination. So with a one-to-one cardinality, that means that there is only one row in table B that matches one row in table A. Right, there's only one possible match from my source to my destination. And when you do that, you would have a join and a one-to-one cardinality. So here we have polygons representing states, and these are my destination. And I have a table with information about the states. This is my source. If I only have one record for each state, I'm going to join them one-to-one. Does that make sense? So I have 50 rows in each data set, and they only match one other field. If I have many records, in my source that match a single row in my destination, sorry, I always get this confused. Many rows in my destination that match one row in my source. This is a many-to-one operation, and I can also join those two data sets together. Any repeating in my destination table, any of these duplicates will just repeat that information. So I'll pause for a second to let you think about that. A many-to-one cardinality here, we're going to just repeat information. So let's say table A, our destination is counties in a state. And my source table is states. It will simply duplicate that same state in my source table however many times it needs to in my destination. Does that make sense? I'll write a quick example. Let's say I have Pickens County, South Carolina. What's a county in Georgia?
Forsyth.
Forsyth. What's another one?
Hart.
Arc.
Hart, H-A-R.
Hart. And I have Oconee. And this is my A, my destination. B over here, I have something for South Carolina. something from Georgia. I have many records in my destination, or my destination, I always get this confused, they match one record here. So I would repeat South Carolina, and then repeat all the information from Georgia as I go.
If it was an extra state in the, like, Florida, would it just get left out?
Yes, if there's no match between the two, then that would not be carried over in the join. Is this making sense? So I'm going to just repeat this information if it's a many-to-one, but I can still join because the relationship between the two is unambiguous. If I have a one-to-many relationship, if I have the opposite of this, where now I have states as my destination and I have counties as my source. How many counties are there in South Carolina? 40 or so? If I'm going to join, which one of those counties do I pick to match to South Carolina? The relationship is ambiguous. If I go down to Georgia, there's however many counties in Georgia, which one do I pick? I don't know. That's a one-to-many cardinality. And you can relate tables in this sense. So you can build a connection between the two where any selection you make in one table will select entries in the related table. So you can still identify and make subsets of the data and have these features linked, but they won't append the attributes between the two.
What's the advantage of joining versus relating?
So in a join, you're working in one single table and you're adding information to that table. In a relate, you're able to link items that have some relationship between the two, but don't fall into these categories. So imagine you have aquifer data, or a table with each hydrostratigraphic unit. And now you have wells, and you may have 50 wells cased in one, 20 in another. You can't join the well data back to the aquifer, but you can relate the two to each other. So if you want to find wells just in my sand and gravel unit, I can relate and find those wells through that relationship. Does that make sense? Sort of. All right. Now, many-to-many is where you have multiple options in one table that would match multiple options in the other. So again, you can relate these two and build a link between these two tables, but we can't simply append attributes between them. So let's do some more examples. This will help. We have a destination table. It has countries, France, Sweden, and the UK, and each one of those have some government ID code, where France is 1, Sweden is 2, the UK is also 2. And here's my source table, where I have countries, France, Sweden, and the UK, and I also have their capitals. Can I join these, or do I have to relate these? I can join them. What type of cardinality is it? One-to-one. And what is our key field between the two? Our country. Yep, so we're going to match any entries between the two. And there's just one record that matches from my destination to my source. Here's my new table that I want to append. Or build some relationship where now I have those government ID codes and this tells me what those represent, whether they are a republic or a constitutional monarchy. So is this a join or a relate? I hear join and relate. How many say join? How many say relate? How many are totally lost? All right, so here we can still join. We have a many-to-one. We're going to repeat that code 2 for both Sweden and the UK and link that 1, the Republic, over to France. So if we have a country and the major cities in that country, is this going to be a join or a relate? It's a relate. Why is it a relate?
3 different cities for France, so if you selected France, it would know which city.
Right, there's 3 different cities for France. Which one are we going to pick? We have no biases here. We have to relate. We can't join those features together. But anytime I select France, I could identify those major cities within it.
If you were, sorry, so I get, it was join for the many to 1 because it was relating back. Because the destination table had.
So, okay, I'll go back one more. So for the many to 1, we can join because we can duplicate or repeat any row in our source table multiple times in our destination.
Okay.
So here we would join France would get the Republic code.
Right.
Both Sweden and the UK would have this attribute.
But if those tables were reversed and the destination table was the, was the one with the ID and the type of government, would that then be a relate because there are 2 countries who have a constitutional monarchy?
Yes, exactly. If we were to reverse those 2 tables, it would have to be a relate similar to this because now we have 2 countries with that constitutional or that government ID of 2. Sorry, I had it back. And we don't know which one of them is going to append to the end of it. Yeah, so for this example, it's a 1 to many. We have multiple Frances, multiple UKs. We can't simply grab one city and slap it on at the end of France.
So when it says 1 to many, like in this idea, is the one side of the thing, is that the destination table, and then the many side is B, so okay.
Yep. So the convention, going back, is destination to source. 1 to 1, 1 to
Okay.
many to 1. Yep. Good. Any other questions? Does it make sense? All right. So what this actually looks like in the software, an example here are 2 tables. On the left is an example of a table you often see for polygons you download from some database. So maybe these are states, maybe they're counties. They may have some code, in this case, this SDFID, state FID. But that's all the information we have. We don't have any attributes about the states. We can bring in another table that has, say, population density, household data, demographics, whatever we're interested in, and append those attributes by linking that state FID code. And so what our join data dialog looks like this. We set up that we're going to join attributes from a table, and then we select the attribute field from our destination table, and then from our source table. And here near the bottom, you can keep all records, which means if there's no matching between the 2, it will have some null values left in the table, or it will remove those that don't match and remove those null values. So keep only matching records. Whoops, got behind here. So once we perform that join, you can see the resulting table here where now every polygon representing a state has a population density, and so on. A really important step here, just like we validated our attribute queries, is to validate our joins. Joining is very, very picky. It requires your data to be very clean and properly formatted. So what the join validation tool will do is look for any potential problems. So it's going to look through your field names, and any of those that start with or contain special characters, it will alert you. It will say the join will not work because you have special characters. It will look for field names that match, right? So is California equivalent to California with a lowercase c? It will also check and make sure that you're joining the right the right attribute format. So you're joining text to text, numbers to numbers, right? So a string 1, here shown here in quotes, is not equivalent to 1, the number. And it will also tell you if you're using a reserved word in your attribute table. This won't always cause a join to fail, but it can cause problems. So before you join, we run that validate join tool, and it will alert you to any problems. So relating tables looks very, very similar here. We're going to specify those fields that match between our two tables. But again, we're not going to append attributes from one to another. It will just show us that when we make a selection in one table, the related table will also show that selection. Questions? All right, let's do it. Let's go back to ArcMap. We are done working in this map document for now. If I go to my Arc catalog to my Working with Tabular Data folder, I'll expand that one, and there's this joins and relates map. And we can open that map document by double clicking on it. We don't need to save any changes to our current map. So what we're going to do is take a look at a few different data sets in the state of Oregon. So we're going to start with some empty, boring geometry and an boring table, and then we're going to join the two. And then we're going to also summarize our tables and build up some relates. And we'll do multiple joins to show you that compound joins are possible. You can add or link multiple data sets and tables to each other. So I can close my business analyst window if I get this message. And here is our boring geometry to start with. Right? This layer we're looking at is our Oregon tracts in 2010. So some of our census tracts. So this is really just a cartographic boundary. Once ArcMap catches up, I'll open my attribute table and we'll inspect that. Up yet? All right, here we go. So I'll right-click my Oregon tract layer, open that attribute table, and I see there are some codes: state FP, county FP, tract, a name, the shape length and shape area that are automatically created for geodatabase feature classes. But there's really no information, no data here. So we have a table that contains all of our, that contains some population and demographic data. And so we're going to add that. We're going to add that in. So if I expand my joins and relates geodatabase, I see there are some single tables within that geodatabase. Some standalone tables. Let's add this one called OR, Oregon Tract Tables. Drag and drop that to the map document. And then go ahead and open that attribute table or table. So here I see a year, some regional codes, a state. I have counties, tracts, and then here at the end, under the names total, white, black, American, Indian, Asian, Pacific Islander, and other. Right? Some demographic information for each of these census tracts. So let's create a join between the two. We're going to append this track table to our tracked polygons. What's our key field that we'll use to link the two?
GIS join.
GIS join, that's a nicely labeled field, right? Between the two, I have GIS join. So we are going to use that code as the basis for our join. I'll close my attribute table and get it out of the way. So to set up a join, we'll right-click our Oregon Track 2010 polygon layer. And underneath Open Attribute Table is the Joins and Relates option. I'll hover my mouse on that and then click on Join. Again, I right-click my Oregon Track polygons, hover my mouse over Joins and Relates and click Join. So then I get my Join dialog. We want to join attributes from a table. For part 2, it will, this is where you select the table or data set that you're trying to join. We want Oregon track tables. For step 1, choose the field in this layer. We'll go to the dropdown, click GIS join. And then it guesses that I want GIS join in the other data set, which I do. We'll keep all the records, but click on validate join. And what does it tell you in our box here?
It's matched.
It's matched everything. 827 of 827 features matched. But it's also warning us that year may cause some problems. So let's go ahead and see. I'll click close on my validation report. I'm going to keep all records and then click OK. Then I'll open my attribute table once again for my Oregon Track 2010 layer, these polygons. And now I see all these new attribute fields. Say all that census and demographic data.
Is it because a year is the same?
It's because year is an access database reserved word.
Okay.
It just doesn't like you to use that word as a variable because it can cause problems.
Should you use annual?
I don't think I've ever seen it be a problem for me, using the word year, but if you have problems with the join and you can't figure it out, that could be it. Yeah, use ano, right? Okay. So how hard was joining on that scale of 1 to 10?
Call it 2.
2. Super easy to set up as long as your data are nice and clean, right? So let's remove our join. I'm going to right-click my Oregon Track 2010 layer, go to Joins and Relates, and then click on Remove Joins and click Remove All Joins. And then watch my attribute table as all my new attributes disappear. Right, so this is a dynamic thing when you join data. When you join attributes, they only live in this map document unless you export the data. So let's set that join up once again. Let's right-click our Oregon Track 2010 layer, go to Joins and Relates, click Join. Choose our field as GIS join, keep all records, and click OK.
What's the process for exporting that back to the layer?
We'll do it again in a minute, but you would right-click on the layer, go to Data, and Export Data, just like we've done in the past. That would preserve all of those attributes in a new data set. So what was the cardinality of this relationship? How many records were there in our destination table, our polygons? And how many records were there in our tracked table? they're about the same. So this is a one-to-one. Every census tract polygon linked to just one row in our new table. So let's do a many-to-one operation. So what we're going to do is add some county level information to each one of these census tracts, because we can repeat that county across all of these tracts. It's a many-to-one relationship. So here in my joins and relates geodatabase is another table, this Oregon County Population Change, or co-pop change. So let's click and drop that into the map. And let's right click it and open it. So here I see I have 37 rows. I have a unit, F2, F3, number, and percent. So these are populations between years and the change between the two, and the percent change between them. So let's join this back to our Oregon Tract 2010 layer, those polygons. But what is going to be our key field for this one? What can we use to match the two?
Object ID?
No, object ID is an automatically generated code. When you create a feature, you'll pretty much never use it to do a join.
Relate unit from population change to county
So we could do,
tract.
so our Oregon Tract 2010 layer where we have our join set up, which field are we going to use? County. So I see each one of these census tracts has the county in which it resides, and my population change table has a unit, and each of these is the county. We're just using a different word. So yes, we could use that. So to add that join, we'll go back to our join dialog. Right click our Oregon Tract 2010 layer. Click on joins and relates. Click join. And it selected that population change table here in the middle. So we'll select county for our first option. And it grabs unit because it already found matching records. So if I click on validate join, it gives me a few warnings again about these names, but it is also telling me that there are 827 matching records. It basically matched all of them again. So if we click OK and start that join, now notice it's repeated that population change from the county for every one of the census tracts. So every tract in Lane County gets the same information. Every tract in Crook, Harney, Lincoln, and so on, they all get that same information repeated because it's a many-to-one operation. So another thing I'll point out is that this was a compound join. We couldn't have joined our population data directly to the census tract polygons. We needed to first join and get that county name, or sorry, the county field from our tract tables, and then match that to the unit field here. There aren't any fields in our population change table that would have matched. Another common operation here with tables is if you want to aggregate data. So if you want to merge data from a bunch of polygons or records into one, you can aggregate the tables. So right now, we had a table of population information for each census tract. Let's say we want to aggregate that so that we have the total population for the county. because each county is subdivided into these individual tracts. We can summarize on the county name, and it will add or average all of these rows that share that same county name into one record in a new table. So let's try that out. So let's add our Oregon County 2010 feature class from our Joins and Relates Geo database over here in the catalog. This Oregon County 2010 polygon layer. I'll drag and drop it. And I'm going to go to my Oregon Tract Tables table. So if you've closed that one, you can right click from your table of contents, Oregon Tract Tables. And we're going to summarize this county field. Is everybody there? All right, so let's right click the name of that county or that field and then click where it says summarize. So what this will do is combine every row that has the same county name with some measure that we define. So scroll down at the bottom here to where it says total, white, black, American Indian, Asian, and so on. And so what we'll do is sum all of these population fields. So if I expand that total, I could take a minimum, maximum, average, standard deviation, variance. I want to click on sum. So I'm just going to add up all these entries to total them for the county. And I'll do the same for my white field, for the black field, for American Indian, and so on. So each of these I'm going to sum up all the census tracts to summarize for the county. Oops. And once you've done that, we need to specify our output table. So I'm going to browse, click that folder icon, browse, and I want to save it in my, I can click home, working with tabular data, go to my Joins and Relates Geo database, double click on it. And I'm going to call this OR_county_population. And click Save. And click OK. I can add that resulting table back to the map. And I'll open it and take a look. So now I see there's only 36 rows, right? One row for each county, and it's added up the population across all these different demographics. And it also tells me how many individual rows it's summarized. So now I can join this data back to, say, my Oregon County polygons, right? I can right click on those, go to Joins and Relates, click on Join, specify my Oregon County population, let me remind myself which field I need. Oregon County 2010. It's the name 10 field is the one we want. So I'll go back to my Joins and Relates and join. Grab name 10, which will match county. I'll validate that join. It says all 36 match, so I'll click OK, and I see all those new population fields. Everybody there? So let's say I want to now export those so I can save my county polygons with that population data. So I'll right click my Oregon County layer, go to Data, Export Data. I'll export all features using the same coordinate system as the source. And my output feature class I'll save in my joins and relates geodatabase. So I'll look in my home folder, joins and relates geodatabase. And I'll call this OR_counties population and save. And then click OK. And when I add that to the map as a layer, I notice those attribute table has all that information. So I can close ArcMap without losing any of my joined data. Questions? How hard was summarizing 1 to 10? 2.5? Yep.
What table did you join Oregon County population to?
I dragged over, so I joined my Oregon County population table from my summary to the Oregon, where is it? Oregon County 2010 polygon layer.
What I thought I did. Okay.
And so when I join those two, I'll remove it. When I set up that join, I use the name 10 field and the county field in my population and validate. Says 36 of 36 matched. Click OK. And then I had all my results here. Back in that county 2010 polygon attribute table. Yeah, I've got a bunch of tables open now. All right. All right, let's do one example of a relate. All right, so we're going to set up a relationship between our two tables without actually appending any attribute information. So let's take our Oregon County 2010 layer. Well, actually, let's start a new map document. Click New, Blank Map. We don't need to save any changes. But we'll pull in our data that we exported with all of that additional information for our counties, and then relate it back to our population table. So I'll drag and drop my Oregon County 2010 layer and my Oregon County population change table. So ORCO pop change, right? And just to remind you, that population change table here will get related, and we are going to use our name 10 field from our counties and the unit from our population change. So we'll use the same fields we did for the join, but now we're going to relate the two. So right click my Oregon County 2010 layer, select joins and relates, and then click relate. And so the field, I want to select name 10 for 1. It will grab unit from my second layer. I'll leave this default name, relate 1, and click OK. So notice my attribute table hasn't changed at all. What I should see as I click through and select one, it will highlight records in my other. Why isn't it? Uh-oh. Did I skip a step? should be selecting the two. If I use my identify tool, it will show this relate. If I click one of my selected counties, so I went to my county 2010 layer, just dragged here along the left and this gray bar to select. And I use my identify tool, click on one of these counties. If I expand that, say Morrow County, I see those attributes for the county. And I also see that population change table. And if I click here, I can identify, or I can see those related attributes from the other table. I'm gonna have to, we're running short on time, so I'll have to look up why those two didn't select between them. Anyway, that's our relate. So we haven't appended any attributes. We can remove that relate just like we did a join. Any questions on that? All right. Then that's all I have for today. So thank you all for your attendance. There's the link to the survey once again, if you could please fill that out. If you didn't mark your attendance, come see me for that. The next workshop we'll do is basic spatial analysis. So we're going to start doing some geoprocessing. So we're going to look at how we can use, say, distances, or we can quantify distances around features. We can do a spatial join, where we can join attributes based on things that overlap in space rather than matching through a table. We'll do all sorts of fun things like buffers to identify subsets of features. We'll intersect things to merge them. Look out for we'll do 2 sections next week, or I should say one next week and one the following week. It'll be a Friday, Thursday, once again. So look out for those links in your email this Monday. So thank you all. If you want to stick around and ask me any questions, you're more than welcome. If not, it's Friday afternoon. Enjoy your weekend. We'll see you next time.
Thanks, Blake.